This is question 2 from the 2008 Mmpc round 2. Consider the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and so on. So each number m appears m times in a row. The question is, find a closed form formula for dn, where dn is the nth term of the sequence. It's much different from question 1, which was simply computation. This one is much more open-ended. You might not even understand the question, what it's asking for, very well. Closed form formula, I would have called this an explicit formula for the nth term, as opposed to a recursive formula, as opposed to a verbal description. So what we're looking for is an algebraic expression for dn. So because we're looking for an algebraic expression of a function, I think it's useful to think about a graph. So when n is 1, when n is 1, d is 1, and then I have the point 2, 2, 3, 2, 4, 3, 4, 4, 4, 3, 5, 3, 6, 3, 7, 4, 8, 4, 9, 4, 10, 4, 11, 5. Okay, so, yeah. When I look at this, I'm thinking, if I'm trying to find a function that will go through all these points, there's not going to be a really good-looking function. I mean, piecewise linear, but the pieces get longer and longer. But anyway, because it's constant on some intervals and always kind of at an integer value, I'm definitely thinking that my rounded down function, my greatest integer less than x, is going to be a critical part of my formula. If I can find some curve that goes through the first dot on each level, and then I round that function down, I should be in good shape. So let me forget about these extra ones and just focus on the first dot. So this guy is at 1, 1, this guy is at 2, 2, this guy is at 4, 3, this guy is at 5, 6, 7, 4, this one was at 11, 5. So now I'm thinking, yeah, the first time that I get to the number n in this sequence, how many terms have already passed by? Well, there's going to be 1, 1, 2, 2s, 3, 3s, 4, 4s, n minus 1, n minus 1s. So if I add up all of those guys, you should know the sum of the first n integers without having to recompute it. The sum of the first n integers is n times n plus 1 over 2. So the sum of the first n minus 1 is n minus 1 times n over 2. So that's how many prior terms there are, and then I get n the first time on the very next term. So in other words, if I have a function, you might be more comfortable with x's and y's, so I'll switch to x's and y's for a second. If I have a function, it should go through point y when x is x minus 1 times x over 2 plus 1. I'd want to know y as a function of x. I know x is a function of y. Well, great. I just have to kind of go through finding an inverse function, right? sorry, I messed that up. The x value depends on the y value. I can't just put x and y variables. They're related to each other. So x equals y minus 1 times y over 2 plus 1. I want to solve this for y, so I'm going to have 2x minus 1 equals y squared minus y. I can see that it's not going to have a unique solution for y. This is going to be a sideways parabola, but I only want the top half of the parabola. So when I take a square root, I'll take the positive root. Looks like completing the square is going to be the easiest way to do this. So I should add 1/4 to both sides. And now I'm going to have y minus 1/2 squared equals 2x minus 3/4. So I'll take a square root. I'll keep the positive root, and I'll add 1/2. So this is my curve. This is my blue curve, right? It's the sideways parabola. It goes through all of the leading points. If I round this function down using a step function, I should get my dn. So this is my function. It looks a little bit complicated, so if I have a little bit of time, hey, small typos like that will cost you a point on the Mmpc. dn is a function of n, not x. If I have a little bit of time, I will plug in some random values for n and try to calculate it, make sure it works out. But for now, I'll move on to question 3 and see how it goes.